Hi everyone, welcome to Day 4, Section 2.4, Writing Equations of Lines. Today we're going to focus on writing equations of lines in slope-intercept and point-slope forms. We'll also write equations of parallel and perpendicular lines. So let's start with a quick refresher of what the formula for slope-intercept form is. So we did this the other day when we were graphing. Can you remember the formula? We get y equals mx plus b. When we're writing equations of lines, we use this equation when we know two things. First thing, when we know our slope, and remember, that's the m in the formula. And two, when we know our y-intercept, and that's the b in our formula. Okay? Before we get into actually writing equations of lines, we want to do a quick refresher of actually graphing an equation in slope-intercept form. So I want you to try this on your own really quickly. Graph y equals negative 2x plus 4, and I want you to remember to label 3 exact points on your line. Okay, so go ahead and give that a try now. All right, hopefully you had a chance to do that. And we recognize that our y-intercept is 4. So the point we are plotting is 0, 4. So if we go and plot that, we get a point right there. And our slope is negative 2. So from our point 0, 4, we can go down 2 units and over 1, getting us to the point 1, 2. We could go down 2 again and over 1, and that gets us to the point 2, 0. I could have also gone up 2 and to the left 1 from our starting point, and that would have been the point negative 1, 6. So those are all good points. Now we should have drawn our line through, and hopefully you got something that looks like that. Okay? So hopefully that was a quick review and we don't have many questions on that aspect. Now let's go ahead and get into writing equations of lines. So to get started, let's look at these examples and we'll write the equation for the line with the given information. So example 2, we have a slope of 4/3 and a y-intercept of 7. Well, remember the criteria we need in order to write an equation in slope-intercept form. We need our slope. In this case, we know our slope, m, is 4/3. And we need our y-intercept. In this case, we know that our b value is 7, so we can just write it right into our formula of y equals mx plus b. And we get the equation y equals 4/3 x plus 7. And that's all we need to call it a day. Okay? Alright, so I want you to try the next two examples on your own. Example 3, you have a slope of negative 1/4 and it passes through the point 0, negative 2. And in example 4, you're writing the equation of the line given to the right. So go ahead, give those two a try, and then start the video back up. Okay, hopefully we had a chance to try both of these, and we should recognize in example 3 we have all of the information that we need in order to write our equation in slope-intercept. We have our slope, so in this case m is negative 1/4, and this ordered pair, that is our y-intercept. When x is 0, we have a y value, therefore our b value is negative 2. So we go ahead, we write our equation, y equals negative 1/4 x minus 2. So hopefully you did all right with that one. In example 4, we had to do a little bit more work this time. If you take a look at the graph, you should identify we do have our y-intercept. So we have our b value. Our b value is negative 1. We don't have our slope. So we can calculate our slope because we should recognize that this other point that's given is 1, 3. So we need to do a little bit of a calculation before we can go ahead and write our equation. So if you remember from the other day, the formula for slope is y2 minus y1 over x2 minus x1. So let's go ahead and plug these values in to find our slope of the line. So negative 1 minus 3 over 0 minus 1. We get negative 4 over negative 1, and we always simplify, so we get a positive 4 for our slope. Now we have all the pieces of information we need to write our equation, so let's go ahead and do that. We get y equals 4x minus 1. Alright, let's move on. Okay, so the next thing we need to talk about is vertical and horizontal lines. Alright, we kind of talked about these the other day when we discussed slope, but we did not talk about the formula for the equation of a vertical line. So a vertical line is when x is equal to a constant. So we have where C represents a constant. Okay, and if we remember our slope of a vertical line, we discussed this the other day, the slope of a vertical line is undefined. Because remember, it's rise over run. Well, a vertical line has an infinite rise, but it doesn't run anywhere. So when you have a 0 in your denominator, it's undefined. Okay, so let's go ahead and graph the line x equals 4. So we just go out to where x is equal to 4. 1, 2, 3, 4. So it's right here. And we go ahead and we draw our line through that. And it certainly doesn't hurt to label a few points on this line. So we can start with the point 4, 0. And then maybe I just choose a point up here looking at 4, 4. And then maybe over here we're at 4, negative 4. Never hurts to include 3 exact points on a line, even though it's vertical. Okay? Alright, so moving on to horizontal lines. Horizontal lines, the formula is y equals c. And c again is just some constant number. Okay? The slope of a horizontal line we talked about. The slope of a horizontal line is 0. Okay, remember this time it has no rise but an infinite run left to right. So when 0 is in your numerator, it goes to 0. Okay, so now let's go ahead and graph the line y equals negative 7. So we can go down to the point 0, negative 7. Okay, and we've got a horizontal line that passes through this point. I'm a little off here. And then we can label some points here. So we have 0, negative 7. Maybe I choose the point 7, negative 7. And maybe I choose negative 7, negative 7. Okay, again, always helps to include 3 points on the line. All right. Let's go ahead and talk about the next formula, point slope. Okay. So point slope formula is the following. It is y minus y1 equals m times the quantity x minus x1. Okay, here we have our slope m, and the point that our line passes through is this x1 y1. Okay? So we use this formula, we use point-slope form to write an equation when we know our slope and to a point other than our y-intercept. Okay? So if I know my y-intercept, we're going to use slope-intercept. But if I don't know my y-intercept, point-slope is the best form to choose. Okay? So before we get into actually writing equations in point-slope, we need to get the idea of how do we graph out of point-slope. Okay, so let's look at this example 5 where we're graphing y minus 1 equals 3 times the quantity x plus 4. Remember to label 3 exact points. Okay, so the first thing you should be able to identify is our slope. And what's in the place of our m is 3. Okay, now our point, we look at what's with x. Okay, and notice in our formula up above, it's that x minus x1. So in this case, it's x plus 4. All right, that's like saying x minus a negative 4. So therefore, the x value of our point is negative 4. We just take the opposite of what's inside with x here. Okay, and the same idea with y. Okay, so it's y minus y1. And in our equation here, it's y minus 1. So the y value of our point is just 1. Okay, again, you just take the opposite sign of what's with y. All right, so now similarly to slope-intercept form, we plot a point, we use our slope to get to other points. Only this time, our point isn't the y-intercept, it's a different point. So we can go ahead and graph negative 4, 1, and we plot that there. And now we use our slope of 3, count up 3 units, 1, 2, 3, and over 1. And that gets us to the point, let's see, negative 3 and 4. And then we count up 3 and over 1 again to get us to the point negative 2, 7. And we started at the point negative 4, 1. Now we go ahead, we draw our line. Okay? All right, let's move on to the last page of our notes. Okay, write an equation of a line that passes through the point 2, 3, and with a slope of 1/2. Okay, so again, we identify what we're given. We're given our slope. We're also given a point, 2, 3. Now, the only thing we have to ask is this our y-intercept? Okay, and the answer, hopefully you recognize, is no, it's not our y-intercept. So we're going to use point-slope form. So, reminder, y minus y1 equals m times x minus x1. Okay? So we just plug in. Our y1 is 3, our x1 is 2. So our equation, y minus 3 equals 1/2 times x minus 2. No need to ever convert it to slope-intercept form. You leave it in this form and you move on. Okay? All right, I want you to try example 7 really quickly. Write an equation of a line passing through negative 2, negative 6, and negative 3, 10. Here's a hint. You need to calculate your slope. Okay? Hopefully you were able to figure it out. Write it in point-slope form. You could have one of the following equations, depending on which point you use to write your equation. And it doesn't matter which point you choose. Okay? So, we should have gotten y plus 6 equals negative 16, should have calculated that as your slope, times the quantity x plus 2. Or if you use the second point, you would have y minus 10 equals negative 16 times x plus 3. Okay, if you have any questions on that, make sure to bring those to the table tomorrow. Okay, let's see what we remember about parallel and perpendicular lines. Okay, what do you remember, or what do you know about parallel lines? Well, you should think parallel lines will never intersect. So what does that mean about their slopes? Well, if parallel lines will never intersect, that means they have to have the same slopes. And you should have remembered this from geometry. Okay. Also, what about perpendicular lines and their slopes? Well, we should remember that perpendicular lines have opposite reciprocal slopes. So opposite meaning one's positive, the other's negative. Reciprocals just means you take the fraction and you flip the numerator and the denominator. So for instance, if I have a slope of 2/3, then the slope of the perpendicular is going to be negative 3/2. And notice the notation I used here, the perpendicular symbol, that just helps me keep things in order. Okay, so now let's look at example 8, where we're actually writing the equation of a line that passes through the point 4, negative 3 and is parallel to this line y equals 2x plus 5. Well, parallel lines have the same slopes. Okay, so all I need from this equation is the slope. So can you identify the slope of the line given? Hopefully you recognize our slope is 2. Well, since the slopes of parallel lines are the same, the slope of our new line is still 2, and it passes through the point 4, negative 3. Okay, so when I'm ready to write the equation of this line, we have to ask ourselves, what's the best form to write the equation in? And we should notice this point here is not the y-intercept. So point slope is the best choice to write our equation. Okay, so let's go ahead and do that. Remember, it's y minus y1. Well, y1 is negative. So it's y minus a negative 3, so that's like saying y plus 3, equals our slope, 2, times the quantity x minus x1, which is positive 4 there. Okay, so there's our equation, and again, no need to write it in a different form. Okay, now write the equation passing through the point 4, negative 3 that is perpendicular to this line. Okay, so it's the same line, so recognize that the line given has a slope of 2. So what is the slope of our perpendicular line going to be? Well, it's got to be opposite signs, so it's got to be a negative. And what's the reciprocal of 2? Well, 2 is like saying 2 over 1, so the reciprocal of that is 1 over 2. So the slope of our perpendicular line is negative 1/2. Again, 4, negative 3 isn't our y-intercept, so point slope is the best way to go. So very similarly to above, we have y plus 3 equals now negative 1/2 times the quantity x minus 4. Okay? All right, finally, I want you to try this one on your own. Grace buys a used car for $5,900. Monthly expenses for the car, which include insurance, maintenance, and gas, average $180 per month. Write an equation that represents the total cost of buying and owning the car for X months. Okay? All right, so I want you to try this on your own. A key or a hint, you will be using two variables, X and Y. All right? Let Y equal the total cost. Okay? So see if you can come up with an equation, and we'll see how you do tomorrow in class. Have a good night, everybody. Bye-bye.